Hello, it's Steve. Last time we went over converting our tile maps from Godot to tiled, as well as converting our Godot nodes into tiled templates in here. That video was a little longer than I expected, but that's alright. This time we're going to mainly be focusing on getting our Rust Bevy project set up and doing some parsing of XML. So let's get right into it. If you've never set up a Rust project before, I'll leave this link in the description for setting up Bevy, but it does also go into a little bit of setting up Rust. I'm not really going to go into that right now. I'm just going to skip past that and get straight into starting the Bevy project. These commands are a little different than I'm going to do, but let's go ahead and pop into our terminal here, and we're going to just do a cargo init. This is something that'll come with your Rust setup if you don't have one yet. Now let's look at what that does. First of all, everything turned green over here. That's because we added some Git files. So now I can't show you the some of these files in Visual Studio Code because they're hidden, but you see there's the git ignore, the Git file, and the cargo toml file. These were all generated when I ran that command. This is just basically says I'm in a Git repo. You can look up how to do that. This isn't really going to be a Git tutorial. But mainly what we're interested in is the cargo toml file, and that'll also generate a cargo lock file when we run the project. So let's go look at that real quick. So here's a blank toml file. We don't have any dependencies yet. We're going to, and also actually it also generated main RS, I forgot to mention that before, with just a basic hello world statement. So we could run this just now, but it's going to be a little bit more efficient for us to get the first steps of Bevy out of the way first. So let's go ahead and add Bevy from the command line. Bevy is currently at 0.14, and I'm thinking I'm going to try and do the project in that as much as I can. I might have to roll it back to 0.13 at some point, but we'll see what we run into. So let's go ahead and run cargo add Bevy. Now there's also some optimizations on this article that I think I'm also going to tuck in too, so let's get that done real quick. And there we are. These comments, I'll leave. Well, I don't really have to leave this in the description. I'll leave a link to the Bevy setup article, and they go over why some of these are used. Ideally, we would enable dynamic linking, but that's not currently supported in 0.14. So that means our builds are going to take a bit longer. But luckily, most of the build time is going to be in our first build. So let's do that. But before we do that, let's get a very basic Bevy setup in our main Rust. So let's pull in the Bevy prelude package. And let's do some basic app print lining. So we're just going to make something that prints hello world every frame. Let's do that. So to make a Bevy app, we just got to go call app run. So to make a Bevy app, all we really have to do is do app new, and that initializes a new app, and then run. And at this point, this will be a completely empty Bevy app that's running. How to add functionality to this is right in between these two, is to just go ahead and add some systems. My IntelliSense is completely borked right now, but that's all right. We'll just have to live with it. The reason I should have done a compile. The reason my IntelliSense is broken is that I haven't actually compiled the project. I believe what I'll actually have to do is actually run the project one time, or at least build it for Rust Analyzer to realize that this is a Rust project now. So let's go ahead and add the setup function. with our nice little print line in here. And let's see if that compiles. Now the first time you do this is going to take an absurd amount of time, but that's because it's compiling and linking all of the dependencies of dependencies of dependencies of Bevy. Eventually it'll get to a point where you're only compiling and linking like 4 or 5 dependencies, so that won't take nearly as long. Of course, on my computer this is going to take forever right now anyway, so I'll catch up to you when this is done. Alright, and the compilation is done. You can see down here it actually ran and said hello Bevy. I know I said I was going to set this in update, but I forgot and I set it in startup, but hey, there's only one run and it's good to go. So that's cool. That compile took forever. I was able to eat breakfast and start the dishes, so that's nice. The next part of this project that we're going to chip away at is parsing the XML format of the maps. So to do that, let's first not really worry too much about file I/O. That's going to be something later. Let's just throw one of these tile maps into a string. So let's do a const file data, and then I'm going to grab 0, I believe. Let's do this one. So one thing that we're going to have to change in here is obviously the strings have to be replaced. So let me go ahead and do that real quick. So cargo use ROXMLTREE, or sorry, add cargo add ROXMLTREE. Oh, I was spelling it wrong. Whoops. Cargo add ROXMLTREE. Sure. There we go. And then we can also use that at the top. I guess that's short for read-only XML tree. That makes sense, I suppose. We're going to grab everything from that. And we should be ready to start parsing this data. So we're going to start by grabbing the doc from this file data. And that gives us a result, so let's expect, since this is just a test anyway, let's expect that it works. What this does is it turns the results into a document and it panics with this message if it can't find it, which is pretty nice in my opinion. Next, let's grab, so now we have this as a document. Let's grab the data section here. Theoretically, there could be multiple, but like I said last video, we're just going to assume there's only one layer. Since this is a tool that we're making for this one project, there's no real reason to be super generic about it. So that's doc descendants, which grabs all of the tags underneath doc. It grabs all the tags inside the doc, rather. And then we're going to do the find. Now this is a predicate. So we get a node out of that. Luckily the autocomplete is now working, so we can see, hey, that's a node, which means I can check what's in here. I believe it's tag name, yep. And that gives us the name of these here. We're looking for data, and there's only one data, so we're just going to make sure that's equal to data. And we're going to expect that too with a message I don't know, can't find data. There we go. Let's see how it likes that. Up. This expects to be compared, because this is returning an expanded name, and that's just a string. I believe I can just do a direct manual into call here. There we go. That'll, and actually, here's something nice about Rust. I believe if we click here to see the compiler diagnostic, yep, it actually suggests to add .into here, which that's super handy. You need it with Rust because it's kind of a pain. Otherwise, it can be a pain. Usually that's just a skill issue, but for me, it can be a pain because I definitely have those skill issues. All right, print line. And in order, we want to print out, what are we going to print here? I just want to print the internals of this data. So let's check. I believe there's going to be a text. Yeah, that's what we need. That's the text inside the node, which is basically what that is. Kind of like parsing HTML. Now we can't do this because it'll get mad at us. This is just a wrinkle with how print lining works. If we do this, we'll be able to parse whatever this is into a string. Even though it is a string already, it doesn't know that when we're passing it in because it's just a macro. I believe that's why that needs to happen. Anyway, this is looking good as far as I know. Let's get that look. Let's see if we're getting the map data out of here. Go ahead and run the project again. Now, while that's compiling, full disclosure, I definitely copied this from the repo, and I had a bug in here that the map is weirdly off-center. I saved it strangely. Oh, hey, look at that. Well, that compiled a lot faster. I was ready to go for a walk or something, but this time it compiled much quicker. So here's our data. Weird that it's giving us a sum. Oh, I guess .text is going to give us an optional text, so that makes sense. Anyway, not that weird. So what we're going to have to do from this point onward, clearly, is parse this string into a set of tiles. But before we do that, I think we're going to need to start with importing a file specifically, doing it the Bevy way, and actually loading these files in the way that it expects us to. And that's actually where we're going to cut it off for this video. Next time we'll get rid of this eyesore and load our tile data in the correct way, and start thinking about how we're going to start loading in template data and things like that a little down the line. Thanks for watching. Peace.